Top 10 terrifying signals from space NASA is hiding. Starting off this list in our number 10 spot, we have PSR B0943+10. Pulsars are rotating neutron stars emitting regular pulses of radiation, and they have long captivated astronomers with their very precise cosmic metronomes. But in 2011, a particularly eccentric pulsar, the one I just named, challenged established understanding and left scientists scratching their heads. Located approximately 3,000 light years away, this is no ordinary pulsar. Instead of maintaining a steady, predictable pattern of radiation, it displays a very perplexing behavior. Without warning, it spontaneously switches between emitting radio waves and X-ray emissions. This erratic mood swing bewilders scientists. Standard models of pulsar behavior were based on the idea that radio wave and X-ray emissions were tied to different periods in a pulsar's life, not that a pulsar could switch between them at will. PSR B0943+10's unpredictable switches happening over mere seconds shatters this belief. Despite being discovered in the 60s, it wasn't until 2011 that this pulsar's unusual trait was detected, demonstrating that even familiar celestial bodies can surprise us. This pulsar's peculiar behavior provides a very unique window into neutron star physics, challenging our knowledge and understanding of these celestial lighthouses. In our number 9 spot today, we have the Galactic Center radio signal. In 2013, astronomers turned their attention closer to home, or more accurately our galactic home, the Milky Way. Detected by the New Star Space Telescope, an unexplained signal emanated from the center of our galaxy, a region dominated by the gravitational behemoth, the supermassive black hole Sagittarius A. This unusual signal, detected in the radio wave spectrum, posed several intriguing questions. Was it perhaps a signal from a previously undiscovered celestial body, or some unforeseen interaction of known cosmic objects? Or could it be an indication of dark matter, the elusive substance that makes up about 85% of the universe's mass? While the nature and source of this galactic center radio signal remain undetermined, it underscores the cosmic riddles that surround us, even in our own galactic backyard. Whether we're probing the distant reaches of our universe or exploring our own galaxy's heart, these celestial signals remind us that our universe continues to be a grand puzzle, offering more questions than answers. In our number 8 spot today, we have the orphan afterglow. In the cosmic theater, the year 2019 marked a peculiar detection that challenged the norm. Astronomers using the Chandra X-ray Observatory observed a unique phenomenon, an X-ray burst that was strikingly alone, without its usual precursor, a gamma-ray burst. The cosmic enigma was dubbed an orphan afterglow. Typically, gamma-ray bursts, the most energetic explosions in the universe, precede X-ray bursts. These gamma-ray events often indicate the birth of a black hole or a neutron star, and the subsequent X-ray afterglow is the lingering echo of this cataclysmic event. However, the orphan afterglow seemed to defy this established pattern. The solitary X-ray burst appeared without a detectable gamma-ray burst, sparking curiosity and speculation among the scientific community. What could have caused such an event? Was it merely that the gamma-ray burst was directed away from Earth, or were there alternative processes at play? In our number 7 spot today, we have the Vela pulsar glitch. In the cosmos, even the most predictable celestial bodies can sometimes throw astronomers a bit of a curveball. This was the case in 2000 with the Vela pulsar, a pulsar that, despite being one of the most observed and best studied, presented an unexpected event that left astronomers scratching their heads. The event, fittingly termed a glitch, saw the pulsar suddenly rotating faster than it usually did. Located about 1,000 light years away in the Vela constellation, the Vela pulsar is a type of neutron star that emits regular beams of electromagnetic radiation out into space. Since its discovery in 1968, it has become one of the most watched celestial objects due to its regularity, allowing scientists to predict its rotations with impressive accuracy. However, in 2000, this predictable rhythm was abruptly disrupted. The Vela pulsar experienced an unexpected acceleration in its rotation. While this pulsar is known to quote-unquote glitch every 3 years or so, the 2000 event was noteworthy due to its scale. The sudden spin-up was larger and more dramatic than anything observed previously, leading to much speculation and study. This intriguing event challenged existing theories about pulsar glitches and their internal structure. Despite decades of observation, the Vela pulsar reminded us that the universe still has countless mysteries to be unraveled. In our number 6 spot today, we have the Green Bank Telescope FRB. FRB. In 2012, the vast expanse of our cosmos spoke once again, this time with a signal captured by the Green Bank Telescope, located in West Virginia in the United States. This signal wasn't a gentle whisper, but a bold, intense burst of radio waves, a fast radio burst, or an FRB. FRBs are brief yet powerful blasts of radio waves that come from distant parts of the cosmos, lasting only a few milliseconds. The source of the Green Bank Telescope FRB, much like other FRBs, remains an enigma. These fast radio bursts, due to their brevity and unpredictable nature, have been notoriously difficult to trace back to their origin, and this one was no exception. Since their first detection in 2007, FRBs have posed a significant challenge to astronomers. What cosmic phenomena could generate such powerful yet fleeting signals? Theories range from highly magnetized neutron stars to extragalactic civilization. The Green Bank Telescope FRB added another layer to this cosmic mystery, an enigma still being explored and deciphered by scientists across the globe. In our number 5 spot today, we have Tabby's star. This star, which has also been referenced as the WTF star, is an F-type main sequence star which is located in the constellation Cygnus, about 1,470 light-years away from Earth. This star is of particular importance because of the fact that it shows unusual light shifts, which includes a 22% dimming in brightness. Basically, from our point of view, something continually blocks the star, and it likely isn't a planet, because a Jupiter-sized planet would only block about 1% of a star the size of this one. So what could it possibly be? There are a few theories out there surrounding this anomaly, but none are able to fully explain what is happening here. Some believe that it is some sort of uneven ring of dust orbiting the star, and others believe that the star's luminosity fluctuates depending on the efficiency of the heat being transported to its photosphere. These are just two of the theories surrounding this star, but there are many more out there, and at this point, we just don't know. In our number 4 spot today, we have the Black Widow pulsar. Unveiling the drama of the cosmos, our universe revealed an intense astronomical spectacle in 1988. Astronomers detected a fascinating object, a pulsar known as the Black Widow pulsar, or PSR B1957+20. Pulsars are neutron stars, remnants of supernova explosions characterized by emitting regular beams of radiation as they spin. However, the Black Widow pulsar stands out from its kin due to a unique and somewhat macabre characteristic. Located approximately 6,500 light-years away from Earth in the constellation of Sagittarius, this pulsar is locked in a destructive cosmic dance with its companion star. As they revolve around each other, the pulsar's intense gravitational pull and radiation are steadily vaporizing its unfortunate partner. The process resembles a venomous black widow spider consuming its mate, hence the name. The pulsar's companion, initially comparable in mass to our sun, is now merely a tenth of that, stripped away by the relentless energy of the Black Widow. The radiation emitted from this process is intense and rhythmic, like a cosmic lighthouse casting regular signals into the depths of space. Despite the seemingly predatory nature of the Black Widow pulsar, it provides astronomers with an exceptional opportunity to study the effects of extreme gravity and radiation on stellar bodies. This astronomical phenomenon encapsulates the sheer power, violence, and strange beauty of the universe, reminding us of the dynamic and often brutal processes at play in the cosmos. In our number 3 spot today, we have Hoag's object. Okay, so there are different shapes to galaxies. That's not the weirdest thing in the world. You know that we live in a spiral-shaped one. It's beautiful. There are other galaxies called ellipticals that are more like oval shapes, but one galaxy in particular, which is now called Hoag's object, is truly like none we've ever seen. Just realizing, how do we get a name like the Milky Way and then they get a name like Hoag's object? Just would be a horrible name for a galaxy. This galaxy has a yellow core, and this core is surrounded by an outer ring of blue stars that are much younger than the core, but in the middle between the two, there's just nothing, and researchers are completely stumped as to how it could have formed. The galaxy was first discovered in the 1950s, and since then, there is one leading theory as to how it could have been formed, but it still isn't concrete. Basically, the leading theory suggests that perhaps a small galaxy sped through a larger disc-shaped galaxy galaxy, which then created this bizarre situation. But the problem with this theory is that there are no signs of any nearby galaxies that could have served as the sort of bullet in this scenario. If that happened, it also would have sped up the core of Hoag's object, but we can observe it as moving quite slowly, so that also rules out this theory. There have been other galaxies discovered that have some similar characteristics to this one, but none share all the qualities seen in this very bizarre galaxy. In our number 2 spot today, we have the mysterious gap. A new analysis by scientists at MIT of ancient meteorites found something new and very interesting. In the early solar system, there was what is referred to as a protoplanetary disk of dust and gas that rotated around the sun, and eventually it coalesced into the planets that we all know and love today. So this new study and analysis suggests that a sort of mysterious gap existed within this disk somewhere around 4.567 billion years ago, and it was in an area near where the asteroid belt is today. The reason this gap is mysterious is because it isn't quite clear what the cause of this gap was. There are a few possibilities, including Jupiter, during the time when it began to take its shape. Because of its extremely large gravitational pull, it could have pushed gas and dust towards the outskirts, which then would leave a gap in the developing disk. There are other possibilities, but regardless of whatever caused this gap, it is said to have likely served as a cosmic boundary that kept material on either side from interacting with each other. And finally, in our number 1 spot today, we have shooting stars. Okay, so we often look to the night sky in an attempt to see a shooting star, and the chances might be pretty good depending on how light polluted the area is. I mean, either that or you're seeing one of the Starlink satellites, but either way, we know that shooting stars aren't really stars at all, and are instead meteors burning up as they quickly move through Earth's atmosphere. But what if I told you that there really are some shooting stars that are actually stars? Hypervelocity stars were discovered by astronomers in 2005, and it is thought that they occur or form when a binary star system, or a star system that has 2 stars, gets destroyed by a black hole. One of the stars in the system will usually fall into the black hole, which may just send the other one flying across space as fast as millions of miles per hour. It's definitely not the same thing that we think of when we think of shooting stars, but it definitely is quite the galactic event.